Okay, yeah. Welcome back, students. We're going to complete the last section we're going to be studying in chapter 6, and that's volumes by cylindrical shells. Okay, so let us get a red pen, a black pen, I mean. Take this guy out. Okay, we're good. So, section 6.3, which completes the section we're going to learn in chapter 6. It's pretty much volumes by cylindrical shells. All right, so we completed section 6.2. We learned the washer method in the case where you have two curves. We talk about the inner radius, we talk about the outer radius. We actually did quite a number of examples in that line. Okay, so but the next thing we're going to talk about is volumes by cylindrical shells. Okay, so what's the motivation of actually studying another kind of method with which you can find the volume of a solid, right? So let me give you an example. Let me just make a sketch, okay? So suppose I have geometry. I have a curve looking like this, okay? So this is just a single curve, right? So suppose you call this guy, say this is R. Suppose this is what you call the big R. Okay, so this curve is given by y equals 2x squared minus sq. All right, so now the question is this. So can we find the volume of this solid, of the solid obtained by rotating this region about the y-axis? Okay, what do you guys think? Pretty much, you don't have to, think a lot about that. I'm just going to tell you guys, the conclusion that is not going to be worth it, right? Not worth it. Okay. So that means we even need a better, a better way to think about it. Okay. So that means the idea of inner radius and outer radius do not work in this case. Okay. So especially because you have to solve this guy for x. How do you do that? How do you do that? Y is non-zero. How do you solve this guy for x? That's practically, impossible, right? Okay. In the washer method case or in previous cases we studied, um, you can find a point of intersection by setting them equal to themselves. In that case, things becomes a whole lot easier. But this is just a single curve. Okay, so you cannot just set it to 0. You cannot just set it to 1. You cannot just set it to s. Okay, so hence we need to study the method of the cylindrical shell. Okay. So, and aside from that, sometimes I need to also say that sometimes it's not convenient actually, to find the volume like before, like in 6.2. You have to think about a curve, you know, where the equation is difficult to solve at the boundary of the region. So sometimes you have complicated problems where it's not just convenient to use the washer method. Then you step it up a little bit, then to use the method of cylindrical shells. Okay. So then, of course, let me just remind you that when you talk about the volume of a cylinder, remember, V is just pi r squared h. Okay. So, but in this case, we have, even a slightly different approach, a slightly different thinking. All right. So I'm going to draw a curve that looks like what I started with. Okay. You have, this is, of course, x axis, this is y axis. Okay, so let me label my axis. Of course, this is X, this is Y. So in this case, suppose we have this guy. Okay, so suppose the distance from here to here is given by, we call the distance x1. Okay, suppose we have another guy here. Okay, and suppose the distance from this guy to this guy is actually s2. Okay, so now let's assume that the height, okay, let's call this guy, let's just call this guy h, which represents the height. Okay, so now in this case, now what are we doing, guys? We are actually getting a slice that is in this case is parallel to the axis of rotation. So here you are assuming that we rotate this region about the y-axis. Okay, so suppose we actually want to rotate this region about the y-axis. Okay, what do we do? So let me just write what I just did in words. So we slice so we actually slice okay, so we slice a piece of the region and we interpret it as what we call the thickness, guys. Okay, of a cylindrical shell. Okay, so with the y-axis as what we call the symmetry axis. Okay. Okay, so over here, of course, this guy, we're drawing a function y equals f of x. So I want to show you guys how the formula for the volume in this case, we came about the formula. Okay, so what do we know, guys? So the cylindrical shell is going to be, we have the so-called the outer cylinder subtracted from the inner cylinder. So here we're not talking about outer radius and inner radius. We're actually talking about cylinders. Okay, and just some second ago I told you guys the volume of a cylinder, which is pi r squared h, right? So but in this case we don't have r, so this is going to be pi x2 squared, this is x2, h, which is the height, minus this is going to be pi x1 squared h. Okay, this is my pi. Now what is common, guys? H is common, right? So I can pull out pi is common, h is common. So I'm going to have x2 squared minus x1 squared. You have h. So this is s2 squared minus x1 squared. Do you guys remember difference of 2 square? Okay. So this guy pretty much is just the average height. Okay. So this guy, or at this level, we're talking about pretty much something like the, the height at one point. We can just call it the height at one point in the interval. What interval, guys? X1, X2. Okay. So I know it might not be, interesting, might not be a lot of fun talking about these theories, just hang in for some second. We're going to, do an example shortly. Okay, so difference of two squares is going to be pi. You do have x2 minus x1, x2 plus x1, and you have the height, which is h. All right, so can we go from here? Now, I want to introduce a little tree, guys, a little tree, guys. So let me write that in red. Now, write 2 here, and write 2 here. Now, if I have 2 divided by 2, that's 1, right? So I'm just introducing 2's, but in essence, it's just 1. So this is pi. So I can have x2 plus x1 all divided by 2. Let me write this well. So this is going to be pi x2 plus x1 all divided by 2. Okay, so multiply this guy by x2 minus x1. You have the h. Now, where do I get these 2 from, guys? I'm just introducing this guy because 2 over 2 is just 1. So I'm allowed to do that. Okay, so this guy is actually what we call the average radius of the shell. Okay, which is just equal to x. Okay, we just call it x. Okay, so this guy, on the other hand, this difference is what we call the thickness, guys, of the shell. And this is given by delta x. Thickness, when you have, like, if you're measuring distance, the end point from the start point, you have x2 minus x1. That's just a change in x. So if I replace this variable now, guys, I have 2 pi. This is going to be x partial, delta x. Okay. All right. So now to put things together in perspective, so I can just write, so the volume of the cylindrical shell is given by, all right, so we have a formula ready. V equals, you got 2 pi. Okay, so you can stick with r in this case, h partial delta r. Okay, this guy is what we call, remember the circumference of a circle, right? This guy is circumference. This guy, this guy is just height. And this guy is thickness. Okay. Okay, something else I want to write, guys. Okay, so the volume of solid okay, by rotating about the y-axis, the region under the curve, what curve we have? This guy from A to B is given by, now there's no major difference, guys. Over here now we're just, we just want to write it in terms of a definite integral. So this is 2 pi. Okay, so since I started sticking with s, guys, so let me just stick with s here. Let me just stick with s here so that I can write 2 pi x f of x dx. Okay, so this is a very important formula. It's a very, very important result. Okay, so this is, keep in mind that this is about the y-axis. Okay. All right, so let's look at an example, guys. Let's start with examples where everything is all going to make sense now. Okay. So we want to find the volume of the solid obtained by rotating about the y-axis, the region bounded by, you got y equals 2x squared minus x cubed on y equals 0. Okay, so I'm going to just split this guy up into some series of steps just for clarity, guys, so that you guys can follow. So let me call this guy step 1. Let me just sketch my curve. The level of step 1, I just want to sketch. That's all I want to do. So if you sketch the curve, this guy, 2x squared minus x cubed, you have something like this. Okay. Now, we're rotating about what axis, guys? So you have to pay attention to where you're rotating about the y-axis. And in the shell method, you draw your slices, or you draw your shell parallel to your axis of rotation. Okay, so that means I can just draw my shell. Okay, keep in mind I'm rotating about the y-axis, and this shell is parallel to the y-axis. Okay, so we're gonna come back to this guy. This is y equals to s squared minus s cubed. Step 2, point of intersection, guys, POI. So how do you do that? You set this, guys. Of course, this is my origin 0. You set these two curves equal to themselves. You have 2x squared minus x cubed equals 0. So we're interested in solving this guy. S squared is common, so you have 2x. You have 2, not 2x. 2 minus x equals 0. So what does this mean? This means x equals 0 and x is 2. So that means on the x-axis, I'm actually going from 0 to 2. So that means this guy here is 2. But think about it, guys. There's this guy. Of course, this guy, this distance is measurable, guys. Okay, so it depends. That distance can be a 1/2, it can be a 1/4, it can be 0.6, whatever. But to be on the safe side, is just x. Let's just call it x. Okay, which is our shell radius. Okay, so the distance between this guy and this guy is the shell radius. Okay, so in this case, what do we do first? We sketch the curve, and then when you sketch the curve, you pay attention to what axis you're rotating. So in this case, we're rotating about the y-axis. So that means you draw a shell parallel to y-axis. Okay, of course, you can decide to draw your shell over here, maybe here, but you don't have to get up to 2, right? So you just draw something close to the left-hand side. Okay, so let's see. Step 3 now, we have to solve. What is the formula for volume? V equals, you have integral from A to B, 2 pi x f of x dx. But my A is 0, my B is 2. So I have 0 to 2. I have a 2 pi. Of course, you have x. What is the function f of x, guys? F of x, the function is just 2x squared minus s cubed dx. And now you just solve this integral. Okay, so the setup is very important. It's very important to get the correct setup. This is 2 pi. I can pull out 2 pi. I'm going to be left with, 0 to 2, 2s cubed minus x to the 2x squared, I mean, s cubed dx. Okay, of course, I have x up front. So if you evaluate this integral, you have 2 pi up front, and then you have a 2x to the 4th over 4 minus x to the 5 over 5, then 0 to 2. Okay, so my volume becomes, you have 2 pi multiplied by 8 over 5. And this is exactly what, guys? This is 16 pi over 5. Okay, so the main, the important thing here is to be able to, determine what is your shell height. And then let's go back to the formula so I can show you guys. All right, so we have the shell height, this h, and then we're interested in the thickness as well. Okay, so those are important. So now, if I even want to, explain further, I can just decide to say, oh, we know the volume is just integral from a to b, right? You have a 2 pi x f of x dx. I can write this in another way. I can just say v equals, in some textbook, you're going to see it written in this way. Now you have, say, a to b. You have a 2 pi, then you have the shell radius multiplied by, you have the shell height. So let me just try to, give you guys an intuitive idea of what we refer to as the shell radius, and as well an intuitive idea of what we refer to as the shell height. Okay, so intuitively, the shell height, think about the shell height. This is just an intuition, guys, something to help you remember this, guys. Okay, so let's just say, let me write it in a way you guys will understand. So this is just like, similar to, okay, so like similar to 6.1, similar to top, bottom, right, left, analysis of 6.1. Okay, of session 6.1. Okay, we already studied session 6.1. So this is just intuitive ideas to help you guys. So shell radius. Okay, so this is actually the distance from the shell to the axis of rotation. Okay, so the previous example, the axis of rotation was the y-axis, and we had the shell, right? So this was the axis of rotation, the y, and then we have the shell over here. So this is just the shell radius from 0 to x. Okay, so now let's even look at another example. So let's look at another example. So example. So we want to find the volume that is actually generated, okay, by rotating the region bounded by, you have y equals 4x minus x squared and y equals x above the y-axis. Okay, so solution. So if, for explanation purpose, I'm going to split again into steps. So let me say step 1, my sketch, x-axis, y-axis. So of course, let's start from the easy one. Y equals x is just a straight line. So but y equals 4x minus x squared is a parabola facing down. Okay, so that looks like this pretty much. Okay. So this guy is your y equals x, but this guy is your y equals 4x minus x squared. Okay. All right, so what do I do, guys? Let's go to step 2. We're going to come back to step 1 shortly. Step 2, I find my point of intersection, POI. How do I do that? I set these guys equal to themselves. So I have 4x minus x squared equals x. So this means that I do have a 3x minus x squared equals 0. Okay? So I need to solve for x. X is common. You have 3 minus x equals 0. So what does this mean, guys? It means that x is either 0 or 3. Okay? X is either 0 or 3. Okay? So let us see. So now this point, right, this point of intersection, of course, you need to know this guy is just 0, 0, right? But this point of intersection is going to be 3, 3. How do I know that, guys? Okay, I'm going to show you guys now. All right, so here is 3, 3. How do I know that? When x is 3, you have the curve y equals x. When x is 3, that means your y is 3. So put this guy in coordinate form, you have 3, 3. Okay? So if you use the second equation too, it's going to be the same thing. Okay, so this is a way to think about it. If I decide not to use this equation, let's use this guy. When x is 3, you have y equals 12 minus 9, and that's still 3. So whichever way you go, think about it, you have this guy. Okay? So get step 3, guys. At the level of step 3, we're just ready to solve. Okay? What is the formula? I have my volume, which is this guy. I have 2 pi. Then remember, I have my shell radius. Then I do have my shell height, dx, right? This is a simple way to think about it. Very simple way to think about it. Okay? So pretty much if you look here, you have 2 pi x. Okay? So this is your x. This is like your f of x. So now what do we talk about the shell height? You said the shell height, is similar to 6.1 when we do top, bottom, or right, left. Okay, so I'm going to let you guys know that. So you have, I'm going from 0 to 3, right? Obviously, I have a 2 pi. My shell radius is just x. What about my shell height? So let me go back to my curve. Okay, so in this case now, do we talk about the top curve and the bottom curve, or we just talk about right and left? Okay, so it's the top and bottom because you have a curve on top, then you have a curve on the bottom. So top and bottom. So you do have right now, you're going to have over here, you have 4x minus x squared minus, what is the curve on the bottom? X, dx. And this is 0 to 3. You do have a 2 pi x. This is 3x minus x squared dx. Okay, so right now life is becoming so much easier. So this is 2 pi. You have a 0 to 3. Distribute x, you have 3x squared minus x cubed. Then you have a dx. So right now we're good to, do our integration. This is 2 pi. This is exactly going to be x cubed minus x to the fourth over 4 evaluated at 0 to 3. Okay, so let us evaluate this guy and see what we get. So v is 2 pi. Plug in the top, you have a 3 cube, right, which is 27, minus you have 3 to the fourth, that's 81, right? 81 over 4. If you plug in 0, it's just 0, so you don't have to bother about that. So let's just do the algebra. So if you do the algebra in this case, you want to ensure they have the same thing on the bottom, right? If they do have the same thing on the bottom, so that means you have 108 over 4 minus 81 over 4. This is a very simple algebra, guys. Okay, just ensure they have the same thing on the bottom. So this is going to be 2 pi multiplied by 108 minus 81, you have 27. So at the end of the day, my volume is going to be 2. My volume is going to be 27 pi over 2. 27 pi over 2. Does this make sense, guys? Okay, so we have, other example. Now, this next example uses a slightly different idea, but we can, definitely follow through and understand it clearly. So here we want to find the volume of the solid obtained by rotating the region bounded by y equals x minus x squared, and you have y equals 0 about x equals 2. Okay, interesting question, guys. Interesting. So think about this in a second now. If you want to solve this from everything we've said so far, can you do it? So if not, just follow this closely. So step 1, okay, I just like to fix my step 1 for explanation purpose as a sketch. If I sketch in this case right now, I have so what do I want to sketch? I want to sketch x minus x squared, right? So, and that's just parabola facing down. Now this guy says about x equals 2. So that means this is x-axis, this is y, right? X equals 2, let's suppose we have x at this point. So that means I'm doing a rotation at x equals 2. Interesting. So that means at this point 2, I'm going to draw this guy. Why? Because my slice is going to be, this is at 2, so I just draw a line. So think about it for a second, guys. Over here, this is my s equals 2, right? And my shell has to be parallel to this guy. So that means I have to think about, in this case now, if I like, I can just come here and draw my shell, okay? All right. I can draw my shell there, But of course, I don't have to get up to, I don't have to draw it at this last edge. So you can draw it, I'll place here. Okay, so think about it. If you place a mirror on this line, what happens, guys? You can reflect this guy on the opposite side. So that means you have something that looks like this sort of reflection. If you reflect, then this shell comes over here. Now we're coming back to this sketch, guys. We're coming back on second. So step two, what do we do at step two, guys? POI, point of intersection. So how do you find a point of intersection? Set this guy and this guy equal to themselves. So you have a x minus x squared equals 0. You have x, then you have 1 minus x equals 0. What does this mean, guys? It means x is even 0 or 1. So that means this point is 0. This guy has to be 1. Okay, so what is going to be my shell radius, guys? Okay, or perhaps what is going to be my shell height? We will see. Okay, so let's solve. Okay, so now remember, we said the shell radius is actually the distance from the shell to the axis of rotation. So now what does that mean, guys? So it means this is my shell, right? The distance from this shell, what is the axis of rotation? This guy. So this part. So we don't know what this distance is exactly. Let's call it x. So if this is x, what is going to be this guy? This is going to be 2 minus x. Okay? That's going to be exactly 2 minus x. Step 3, so what is my shell radius? My shell radius is 2 minus x. What is going to be my shell height? My shell height is not going to change, guys. It's still just going to be x minus x squared because this is just one curve, okay? So in this case, if you do x minus x squared minus 0, it doesn't change anything. So you think about it like, okay, it's just a single curve. You have y equals 0, which is just a point. So we're going to put things together now. V equals integral from 0 to 1. You have a 2 pi shell radius, 2 minus x, shell height, x minus x squared dx. Interesting. Correct setup, you have a correct solution. So this is 2 pi, because that's a constant. I'm going to pretty much be left with integral from 0 to 1, 2 minus x, and then x minus x squared dx, which is going to be 2 pi integral from 0 to 1, s cubed minus 3x squared plus 2x dx. Okay, once you distribute that guy, you have that expression. So now, basic integration, guys. So you have 2 pi, you have 2 pi, okay? So, and then, okay, so aside from that, what happens? So right now you do have, okay, so you have x to the fourth over 4 minus you have 3 s cubed over 3 plus x squared, right? Times 2 over 2. Of course, 2 over 2 takes cancels 0 to 1. So pretty much, guys, at the end of the day, once you do this algebra, you have pi over 2. All right. All right. So does that make sense, guys? So if you do that, you exactly have a pi over 2. Okay, so let's do one more example, guys, and then let's see what we, let's see what we will get from there. So in this last example, before I conclude this session in a couple of minutes, in this example, we actually want to find the volume of the solid obtained by rotating, guys, okay, about the x-axis, okay. All right, so the region under the curve y equals square root of x, of course, from you have 0 to 1. We're picking, it doesn't always have to be 0 to 1, guys. So, but we're just picking very simple bounds. So nothing, nothing complicated. So solution, okay. Remember, I just try to fix my step 1 as a sketch. When you sketch the geometry, you actually understand what is going on. All right. So in this case, I have to take note of the keywords, right? So I'm rotating about the x-axis. Okay, so that has an implication. What's the implication, guys? Remember, your shell has to be parallel to the x-axis. So what curve am I sketching? I'm sketching y equals square root of x. Okay, so if I sketch, okay, so let's go this way. You have y equals square root of x. But now I'm rotating about the x-axis. I need to make x subject to the formula. I have x equals y squared. Okay, now because why am I rewriting? Because it's about the x-axis. So I have to sketch the curve y squared. Okay, so which is going to be something like this. Okay, so let me take off this guy for a moment. I'm going to tell you guys why I did that. So, but I can even put it there because, it's pretty much obvious. We're rotating about the x-axis, so we expect a reflection on this side, right? That's a complete curve. Okay, because we're rotating about the x. Okay, so what do we do now, guys? All right, so what other information do we have? We have that this guy is from 0 to 1, right? So that means this point is point 1. So but keep in mind that my shell is parallel to my axis of rotation, okay? So shell is parallel. Okay. So now what did we call the shell radius, guys? We said the distance between the shell to the axis of rotation. So that means this part to this part is my shell radius. Okay. This is my shell radius. Now x is from 0 to 1. Now when x equals 0, what is y? Y is square root of 0, which is 0, right? When x equals 1, what is y? Y is square root of 1, which is 1. So that means on the y part, so you are going from 0 to 1. Okay? So, but how do I know this distance, guys? How do I know this distance? So this distance, this is some point on y, right? But to be on the safe side, I don't know if it's going to be a 1/2. I don't know if it's going to be like 3/8, whatever. So, but to be on the safe side, I'm just going to call this guy small y. Because yes, it's something on y, but I exactly don't know because I'm not drawing to scale. Okay, so just call it a y. So now, yes, we do have the shell radius now. Okay, so step 2. We already have the bound, so we don't have to do point of intersection. We know it's from 0 to 1. Okay, so now we just solve. So we know that the shell radius is exactly what, guys? In this case, it's just a y. Okay. Okay. So in this case, what is going to be the shell height? Okay. So the shell height pretty much is going to be, you have 1 minus y squared. Okay. you have a 1 minus y squared. So of course, in this reflection too, you definitely have the same kind of shell. Just so that you can see what is happening on that side too. Okay. So what is my volume? My volume is 0 to 1. What is the shell radius? I have a 2 pi, remember. You have the y. What is the shell height? You have 1 minus y squared. Okay. You have a 1 minus y squared. At the level of the shell height, this is what we're interested in, this portion. That portion is just 1 minus y squared. Of course, dy. So this comes back to a very easy integration. So this is 0 to 1. You have a y minus y cubed dy. And my volume is exactly going to be what, guys? So you have a 2 pi y squared over 2 minus y to the 4th over 4, 0 to 1. If you do this guy, this is exactly going to be pi over 2. So some of this, in 6.2, if you look at the lecture 6.2 notes, you find out that we solved exactly the same question using the washer method. And now we're using the shell method. So for some problems, you can use both methods can actually work. But in some other cases, you could have complication, and the best thing to do is just to use the cylindrical shell. Okay. So I hope this gives you guys, a good sense of the idea of, volume by cylindrical shells. Of course, we'll see in different perspective, why the motivation of doing this, and then why it is necessary or perhaps important to study concepts such as this. All right, guys. I hope this makes sense. And then